Right, so we've gone through question 10, 11 and 12 slowly. I'm going to summarize each one. So if you follow along as best you can, hopefully this will make a bit more sense now that we've gone through it more slowly. The first question then is we've got a right angle triangle and we've got these coordinates. Now, the ones they gave us was 30, 70 and then 54, 0. And then we had to work out everything else after that. Our real question was to find out what is P, Q, and R. What are the coordinates at P, Q, and R? And what they told us was that these are the halfway points of each line. So the trick was first to find out the coordinate of this. Well, I found that what was quite useful to do was to find out the coordinate at this point here. Okay. Now, because it's vertically below this point, it's going to have the same x coordinate. Remember that these, if something has the x coordinate, tells you where on the x axis, this horizontal line, it is. And if that's 30, then every point along this vertical line is also 30. So that's going to be 30 down there. And because it's down at the bottom, the y coordinate will be 0. And so therefore P will also be 30 on the x coordinate. How do we work out this bit? Well, what we did next is so what did we do next? Oh yeah, the next thing that we did is we were like, well, if the vertical line on the left-hand side, the height of this triangle, if that starts at 0 and goes all the way up to 70, then the halfway point between 0 and 70 is 35, because 70 divided by 2 is 35. So there we have the coordinates for P is 30 and 35. Q was a little bit harder because it started at 30 and went down up to 54. So we need to use that to realize that the length of the base of the triangle is 24. And so therefore halfway along, which is where Q is, would be 12. But because it started at 30, it's going to go up to 42. So the x coordinate for Q is 42, and it's 0 because it's on the x axis. It's always 0 here. If it's on the same horizontal line, it's going to have the same coordinates as these other points. So 42 and 0. That's Q. Now R is in some ways the hardest one, but once you get it, it's actually the quickest one to work out. Because if it's the halfway point from A to C, it's actually going to be the same height as P and it's going to be vertically above Q, because basically as I go halfway, if I go from the end, so I'm looking at the horizontal line now, and I go all the way to the other end, and I go halfway along, I'm going to be halfway along the base, but I'm also going to be halfway along that diagonal line. So R is going to be directly above Q, and so therefore the x coordinate must be the same, so it's 42 in the x coordinate. And the same sort of idea for the y coordinate. It's going to be the same height as P, so therefore it's going to be 35. So those are the coordinates for P, Q, and R. We didn't bother writing them in because we wrote them on the diagram. Right, 11. We have a table here, and it's giving us the mean rainfall. Now, just to be clear, what does it mean, 10 centimeters a month? It means that if I had a container, sat it out in the rain for a month, it's going to fill up to 10 centimeters. And the thing is, and I won't go into the reasons why, because it's interesting, but it's kind of a bit of a tangent. It doesn't matter the width of the container. It will always be 10 centimeters. So if I've got a different container, even though that's thinner than that one is also going to be 10 centimeters high. So that's why we don't measure the volume of rain. We measure the height of the rainfall. Anyway, the point is, in the dry season, it's 10 centimeters over the month. Over the wet season, it's 20 centimeters over the month. And on average, and then for this one it's 5 and 50. But the length of the dry season and the wet season is different for each place. So for the first one, what we did is we realized, well, in total over the 8 months, it's going to be 8 times 10, because it's 10 on average per month. So over the total of the 8 months, it's going to be 8 times 10, which is 80. For the 20 centimeters per month, it's going to be 20 times 4, which is also 80. And for this one, it's going to be 10 times 5, which is 50. Then the bottom one, 50 times 2, which is 100. So what we do then is, well, what's the total amount of rainfall over the course of the whole year? Well, the bottom one, place B, would be 150, and the top one is 160. So which one has the more rainfall? A, because in total there is 160 centimeters of rain, but B has only 150. That's 11. Right, don't forget to always look back on these videos if you think, I can't remember how we did that question or whatever it is. Right, 12. Okay. This is thinking distance and braking distance, and then stopping distance. Now, the thinking distance, what is it? It's the distance you travel whilst you're reacting to what it is that you need to stop for. So the example I gave was, you're driving a car and you see a cat come out in the middle of the road. You don't stop, you don't press your brakes instantly, because it takes a moment for you to react. And whilst that is happening, whilst you're reacting, you're moving. And depending on how quickly you react, that will affect how far you travel. And also the speed you're moving at will affect how far you travel whilst you're reacting, whilst you're thinking, I suppose. So we call that the thinking distance. Then once you've pressed the brake, now your job is done, and now you have to put your faith in the car and the road and the brakes and the tyres and the wheels. And that the distance you travel while your car is braking is called the braking distance. So it gives you an example: 30 miles per hour. If you're traveling 30 miles per hour and you see something come out in front of you, it's going to take you a total of 75 feet to come to a stop. And 30 of those feet you're reacting. That's your thinking distance, and the braking distance is 45 feet. And then it gives you this formula of how to work it out. The thinking distance is just the same as the speed. So this is a little bit of algebra, and it's quite similar to the kind of things you're going to be doing a lot in physics. The braking distance is a bit more complicated. You take the speed and you times it by itself, so you square it. Then you divide it by 20. So we use that as an example to show how they came up with 75 of the total stopping distance. And we had to do the same thing for this one. A car is travelling at 70 miles per hour, so the thinking distance will be 70. The braking distance, you times 70 by itself, you divide it by 20, you get 245. Then you add them together, you get 315. Okay, and this last one, what you have to do is in reverse, and I'm going to do that one myself on the video. So we've got a different car is travelling so that its braking distance is 125 feet. How fast is the car travelling? Well, we know that this total stopping distance is going to be equal to the thinking distance plus the braking distance. The thinking distance is v, and the braking distance is v squared over 20. So it's going to be v plus v squared over 20. Okay, so we could say, and we know that is, in this case, the total amount is 125 feet. So v plus v squared over 20 is 125 feet. I'll just put 125. We'll forget about the units for the moment. Okay, what can we do next? Well, this is quite tricky actually, but let's see if we can work it out. So v squared. Oh, wait, no. Okay. I was going to say that did seem really hard. And I was just wondering if there was a trick. Luckily, it's not that hard. It says the braking distance is 25. If it was a stopping distance in total, that would be much harder. Okay, just the braking distance, right? So v squared over 20 is what the braking distance is. In this case, it's 125 feet. We need to rearrange. So we're going to multiply both sides by 20. V squared is equal to 125 times 20. Now we can do that on our calculator, but let's just do it in our heads anyway, just to show you how to do it. So what I do is I just times it by 2, and then I times it by 10. 125 times 2 is 250, then timesing it by 10 is 2,500. Now next, that's what v squared is. I don't want v squared, I want v. So I'm going to square root both sides. So the square root of 2,500, which I think is 50 if I'm not mistaken, because yeah, I'm gonna just make sure I'm not doing anything silly. Yeah. So so therefore, because 50 times 50 would be 2,500. So the speed that car must have been traveling is 50 miles per hour. Okay, so I'll save that video and put it here, and I'll send it over to your mum. Yeah.